As a starter activity today, I'd like to do a little error analysis. We're going to look at 3 different problems, and we're going to see if we can find the error made and then correct it. Here's our first problem. Take a look at this problem. It's a multi-step, and there appears to be at least one step wrong. And sometimes when one thing goes wrong, the entire solution is incorrect. After you find the error, identify it, and then make the corrections. When you're done with the first, take a look at our second. Again, it's a multi-step equation with an error. See if you can find it and correct it. And then there's one more problem. On this last problem, we're going to be looking at another multi-step equation, and we're going to look for and correct the error. We'll discuss these in class. Today's lesson is solving equations with variables on both sides of the equal to sign. Some equations that you'll encounter you'll find that there'll be variables on the left as well as variables on the right. To solve these types of equations, the first thing you should do is collect those variables on one side. So we sort of say we'll collect them or we'll gather them to one side. Now, even before that, if there happens to be something to simplify, whether you see parentheses or like terms, I would do that first. But if there's nothing to simplify, and as you're looking at this first example, there is nothing to simplify on the left or the right, we think about this equal to sign as separating this into 2 parts. If you notice that terms are like each other but on opposite sides, then we have to use our inverse operations in order to isolate the variable. So in a problem like this, when there is variables on both sides, we generally collect them to the side where they are greater. So with one inverse operation here, addition property of equality, we'll add 2x to both sides. I now have 9x plus 19 equals 55. Now I can just go ahead and continue to solve this problem. I will subtract 19 on both sides and then simplify. And divide. And I get a solution of x is equal to 4. If I'm not sure if that's right, I go ahead and I check it. And again, I would replace 4 in both of these places, and then I would do the math. Linear equations do not always have one solution, but in our experience in class so far, we've only come across equations with one solution. Today, things are going to change. We're going to encounter identities, and in an identity, we're going to find out that there could be any value for x that will make the statement true. There'll be other equations that we'll encounter where there will never be a value for the variable that will make it true, and those are the no solutions. So let's take a look at some of those possibilities. Now recall that I said that if there are variables on both sides, we need to gather them to one side, as we did in the last problem. However, there's something to simplify, so we'll do that first. I see parentheses, so I will distribute. 3 times x is 3x, and 3 plus 2 is 6. If you notice something, 3x plus 6 is equal to 3x plus 6. So right away, I'm noticing that they are the same on both sides. I'm going to continue with the problem, and I'm going to subtract or gather my variables on one side. When I do this, I'm going to see that my variables cancel out. I'm now left with 6 is equal to 6. This is called an identity. And when we have an identity, we're going to realize that x could be equal to all real numbers. Sometimes we just say that x has infinite solutions, or this equation has infinite solutions. You can write either one, but you need to tell me that you know that there are infinite solutions to this problem. And what exactly does that mean? That means I can pick the value of 2. Well, 2 plus 2 is 4, and 4 times 3 is 12. And 3 times 2 is 6, and 6 plus 6 is 12. I could pick 5. 5 plus 2 is 7, and 7 times 3 is 21. 5 times 3 is 15, and 15 plus 6 is also 21. Any value of x will make that a true statement. So when we get an identity, then we're going to see that we can have all real numbers. So in the first multi-step equation with variables on both sides, we had one solution. In our second one, we have infinite solutions. Let's take a look at a few more examples. Once again, I do see a lot of variables in this problem. I see 3 variable terms. The first thing I need to do is simplify. Let's simplify the left by distribution. 3x plus 6. I go to the second side and I see some like terms. I'm going to combine them. That's a 3x plus 5. I notice I have variables on both sides of the equal to sign, so I am going to collect them to one side by one inverse operation. They cancel on the left and cancel on the right, and I have 6 is equal to 5, which is a false statement, so there is no solution to this equation, which means that there is no value for x that will ever make that a true statement. Did you say we wanted to do one more? Let's try. 5x plus x gives me 6x. I now look at the other side and I see some like terms here as well. The constants are like terms, so let me collect those together, and we see that I have 8 minus 4 is 4. I see variables on both sides, so I'm going to stop and collect them to one side. And once again, I have that same situation where my variables cancel out. I'm now left with 2 numbers. If those numbers are the same, once again, we have an identity. In an identity, we now know that we will have x equal to all real numbers. So in today's lesson, we're doing what we've done before, adding the step that there are variables on both sides, and coming to the realization that there are some equations that have no solutions and others that have infinite solutions. In our class, we'll do some more, and you'll do some practice on your own. I'll leave you with this problem, and we'll meet up in class.